Beneath deserts, chalk cliffs, and forgotten riverbeds lie giants that once ruled oceans with teeth, speed, and raw power. From Nevada's fossil halls to Egypt's Valley of the Whales, these deep-sea predators resurface in stone, each discovery stranger, deadlier, and more unexpected than the last. There are fossils that look impressive, and then there are fossils that stop you in your tracks. Shonisaurus belongs to the second kind. This marine reptile was not a small fish in the sea, it was one of the largest creatures ever to swim in the oceans of the Triassic Period. For decades, its story has been pieced together from bone beds in Nevada and a massive skeleton in Canada. What we know today is the result of almost a century of discovery, debate, and re-examination. The story begins in the 1920s in West Union Canyon in Nevada's Shoshone Mountains. Hikers and geologists noticed strange bones sticking out of the Looning Formation. Later, in the 1950s and 1960s, University of California, Berkeley paleontologists Charles Camp and Samuel Wells led large excavations. They found dozens of huge skeletons. Camp eventually named a new species in 1976, calling it Shonisaurus popularis, which means lizard from the Shoshone Mountains. The discovery site became Berlin Ichthyosaur State Park, where at least 37 individuals can still be seen in a fossil hall. Nevada was so impressed that in 1977 it made the ichthyosaur the state fossil. In 1989, the law was revised to specifically name Shonisaurus popularis. The fame of Shonisaurus grew even more in 2004, when paleontologists Elizabeth Nichols and Makoto Manabe described Shonisaurus sicaniensis from British Columbia. This skeleton, found in the Pardonet Formation near the Sicani Chief River, stretched about 21 meters long. Today, that giant is mounted at the Royal Tyrrell Museum in Alberta and is often called the largest marine reptile specimen on display. Guinness-style record lists love it. Some scientists, however, have argued it should be moved into the genus Shastasaurus, so you may see both names used in books and museums. What made Shonisaurus so interesting was not just its size, but also how it lived. For years, researchers thought the adults were toothless, maybe sucking in squid and fish like a giant straw. New studies from 2022 turned that idea around. Fossils from Berlin Ichthyosaur State Park showed complete jaws and teeth of Shonisaurus popularis. That evidence suggests it was not a gentle filter feeder, but a raptorial hunter. Coprolites and gut contents confirm it dined on cephalopods like nautiloids and also on fish, including coelacanths. In other words, it was an apex predator of the Triassic seas. The site in Nevada has also been reinterpreted. For a long time, people thought the piles of skeletons represented a tragic mass death event. In 2022, scientists argued instead that the Shonisaurus returned to this shallow marine shelf again and again as a birthing ground, much like modern whales. Embryonic bones and small juveniles back this up. The idea of giant reptiles gathering to give birth in a safe, food-rich nursery is both striking and a little amusing to think about. Triassic seas were not only full of predators, they were full of family reunions. Today, Shonisaurus stands as a symbol of the rise of gigantism in the Triassic oceans. It is part of the family Shastasauridae, which produced multiple whale-sized species long before whales even existed. Whether you visit Berlin Ichthyosaur State Park in Nevada or the Royal Tyrrell Museum in Canada, the fossils of Shonisaurus popularis and Shonisaurus sicaniensis tell us about life in a world over 200 million years old. It is a story of discovery, debate, and adaptation, written in stone and still being updated with every new find. Long before human history, the oceans were filled with predators that rivaled anything alive today. Some were fast, some were armed with teeth like knives, and a few combined both speed and power into one terrifying package. Among them was Kronosaurus, a reptile named after the titan Kronos, who was said to have devoured his own children. The creature lived in the early Cretaceous seas of Australia, where the landscape looked nothing like it does today. In those waters, Kronosaurus reigned as one of the top predators, but its story also involves a bit of scientific confusion, heavy plaster, and even dynamite. The first clue came in 1899 when A. Crombie discovered a fragment of jaw with 6 teeth near Hughenden in Queensland. This piece was sent to the Queensland Museum, where director Charles Walter Davis thought it belonged to an ichthyosaur. Years later, in 1924, Heber Albert Longman re-examined the fossil and realized it was something very different. He gave it a new name, Kronosaurus queenslandicus, to honor both the Titan Kronos and the state of Queensland. That name has stuck ever since. A few years later, in 1931, William E. Sheville, part of Harvard University's Australian expedition, discovered the most complete skeleton. Extracting it was not a gentle process. Some bones were removed by dynamite, then packed into heavy limestone blocks and shipped back to Harvard. By 1959, the skeleton was mounted on the wall of the Harvard Museum of Comparative Zoology. It was an impressive sight, stretching nearly 12.8 meters. But there was a problem. Too many vertebrae had been added, and missing bones were replaced with so much plaster that paleontologists later joked about calling it Plasterosaurus. Today, most experts agree Kronosaurus was closer to 9 to 11 meters long, still an enormous predator weighing about 11 tons. Its skull could reach more than 2.2 meters, with jaws that locked together around conical teeth nearly 30 centimeters long. In Queensland, several important specimens provide more details. The holotype, QMF 1609, is the original jaw fragment that Longman studied. At Harvard, MCZ 1285 is the famous mounted skeleton. Another specimen, QMF 10113, revealed fossilized stomach contents that included turtle shells, bones from long-necked plesiosaurs called elasmosaurids, and even shark vertebrae. In 2018, a mandible labeled KKF0630 from the Alaru Mudstone was studied in detail, refining knowledge of how the lower jaw was built. These discoveries confirm that Kronosaurus was an apex predator in the Eromanga Sea, with a diet that could include almost anything smaller than itself. The genus once seemed to have a South American cousin, Kronosaurus boyacensis from Colombia. But more recent research showed that skeleton belongs in its own genus, now called Monquirosaurus boyacensis. That leaves Kronosaurus queenslandicus as the only official species in the group. With its short neck, massive skull, and 4 strong flippers, Kronosaurus was built for speed and power. Its bite could generate forces measured in tens of thousands of newtons, enough to crush turtles and tear apart other marine reptiles. It lived in an ocean that covered much of inland Australia, alongside fish, turtles, and long-necked plesiosaurs. While its fossils have been the subject of debate, plaster, and reclassification, its role in prehistory is clear. Kronosaurus queenslandicus was one of the most formidable predators the seas of Australia ever produced, and its story continues to evolve with each new discovery. In the late Cretaceous seas, there swam a predator so large that even its bones tell a story of ambition and disaster. Fossils reveal jaws filled with pointed teeth, prey swallowed whole, and even scars left by sharks that wanted to bite back. The name of this giant fish is Xiphactinus, and its history is as sharp as its teeth. Xiphactinus was a ray-finned fish that belonged to the order Ichthyodectiformes, which are distant relatives of modern teleost fishes. It lived from the late Albian to the Maastrichtian, about 100.5 to 66 million years ago. At full length, it often reached 5 to 6 meters, making it one of the largest bony fish of its age. Its body was deep and streamlined, with strong fins that gave it the look of a tarpon on steroids. Its mouth carried large round teeth set in sockets, perfect for grabbing slippery prey. The discovery of Xiphactinus began in the 19th century. In 1870, Joseph Leidy named the genus and the type species Xiphactinus audax. A year later, Edward Drinker Cope named Portheus molossus, but paleontologists later found it was the same fish, so Cope's name became a synonym. A second species, Zifactinus vetus, was described by Leidy in 1856 and later clarified by David Schwimmer, based on fossils from the eastern United States. Other names have appeared in the literature, like Saurocephalus thomas and Megalodon sauroides, but today they are all folded into the story of Zifactinus. Its fossils are widespread. In North America, they come from the Greenhorn Formation, the Carlisle Formation, and the famous Niobrara Formation, especially the Smoky Hill Chalk in Kansas. Canada has provided bones from the Pasquascow Formation, the Kanguk Formation, and the Asheville Formation, showing that this fish swam as far north as the Arctic Circle. Teeth and bones are also found in Alabama, Georgia, North Carolina, New Jersey, and Delaware. In South America, remains have been recovered from the La Luna Formation in Venezuela and the Salamanca Formation in Patagonia, Argentina. Europe and Australia have also given records proving that Zifactinus was a citizen of global seas. The behavior of this predator is recorded in some of the most remarkable fossils ever found. The most famous is the fish within a fish. This fossil shows a 4.2-meter-long Zifactinus that had swallowed a 1.9-meter-long Gillicus arcuatus whole. The unlucky fish probably ruptured its captor's stomach, killing them both. This specimen was discovered in 1952 in Gove County, Kansas, by George F. Sternberg and is displayed at the Sternberg Museum of Natural History. Bite marks on other skeletons reveal that sharks, such as Cretoxyrhina mantelli, attacked or scavenged Zifactinus. That was no easy meal, but sharks did not mind a challenge. The anatomy of Zifactinus shows why it was so successful. Its skull and jaws were designed for holding large prey. The varying tooth sizes suggest it could handle different kinds of fish. Juvenile specimens show that even the young were already hunting, much like tarpons along coasts today. Life in the western interior seaway was a dangerous game, with mosasaurs, sharks, and giant fish like Zifactinus competing for food. Museums across the United States display its skeletons. The Sternberg Museum holds the fish within a fish. The American Museum of Natural History and the University of Kansas Natural History Museum also display mounted specimens. Each fossil tells a story of ancient seas where size, speed, and teeth determined survival. Zifactinus, with its deep body, socketed teeth, and wide range, stands as one of the clearest windows into marine life before the end of the Cretaceous. Its name may not be as famous as Tyrannosaurus rex, but the evidence it left behind has made it unforgettable to paleontologists and museum visitors alike. And after all, how many creatures can claim to have died because they bit off more than they could chew? Basilosaurus has a name that makes it sound like a giant reptile. But the truth is more surprising. It was not a lizard at all. It was a whale. Living about 41 to 34 million years ago, during the late Eocene period, Basilosaurus was one of the first fully aquatic whales. Its fossils tell the story of a creature that was long, powerful, and a little strange by today's standards. Scientists recognize two main species: Basilosaurus cetoides in the southeastern United States and Basilosaurus isis in North Africa and Jordan. The history of its discovery adds a little humor. In 1834, Richard Harlan looked at its bones and decided it was a massive sea reptile, so he named it Basilosaurus, meaning king lizard. Just a few years later, in 1839, Richard Owen studied the fossils and realized it was a mammal, not a reptile. He suggested the name Zeuglodon, but scientific naming rules mean the first name sticks, so Basilosaurus it remained. In the 1840s, a showman named Albert Koch even built a fake monster from several Basilosaurus skeletons and toured it around as Hydrarchos. People paid to see the sea serpent until scientists pointed out it was just an oversized fossil mashup. Basilosaurus preferred shallow seas. Basilosaurus cetoides swam in the warm waters of the Gulf and Atlantic coasts of North America. Basilosaurus isis lived in the ancient Tethys Sea, with many skeletons now found in Egypt's Wadi al-Hitan known as the Valley of the Whales. These places were rich feeding grounds and perfect for such a predator. This whale grew to enormous lengths. Basilosaurus setidis reached 17 to 20 meters, and Basilosaurus isis around 15 to 18 meters. A study in 2025 estimated that an 18.35-meter Basilosaurus setoides weighed about 15 metric tons. The body was eel-like, with 66 vertebrae, including 19 in the lumbar region that stretched its trunk. Its ribs were dense, helping it float near the surface. The tail likely had a small fluke, and the whale swam with vertical undulating motions, not the fast strokes of modern dolphins. Its skeleton also reveals tiny hind limbs, complete with a knee, ankle, and toes. These legs were useless for walking or swimming, but may have helped during mating. The forelimbs were flippers, better suited to steering. The skull had a jaw that housed sharp teeth with accessory denticles. Unlike modern whales, Basilosaurus chewed its prey, and the teeth from upper and lower jaws met in occlusion. Bite force studies suggest around 16,000 newtons of power, strong enough to crush bone. Stomach contents give us proof of what it ate. One Basilosaurus isis specimen preserved remains of a cycnodont fish called Pycnodus, a large shark tooth, and most dramatically, juvenile Dorodon atrox whales. The young Dorodon skulls even show bite marks, which means Basilosaurus often targeted calves. The nostrils had moved partway back along the skull, showing the start of the blowhole evolution. Its jaws and ear bones suggest directional underwater hearing, another step towards modern whale biology. Basilosaurus eventually disappeared by the end of the Eocene, but it left a clear mark. It became the state fossil of Alabama in 1984 and of Mississippi in 1981, alongside Zigorhiza kochai. Today, Basilosaurus skeletons stand in museums across the world, and in places like Wadi al-Hitan, they still rest in the desert sands, reminders of a time when a whale called King Lizard ruled the sea.